Alright. Okay. Let's continue. Let me open the table of content first. Okay, we are in this section. If I remember correctly, we have some problem with the example. So let's do some debugging there. Okay, first thing first, maybe I want to try writing the code as is. Maybe before only.c. Okay. Delete. STT, okay. String. CTNTL. Start, okay. And then wait. Do I need this? You know what, let's just try this out. RC folk. Then 0. Folk file, okay. Exit 1. Else if I am trying not to copy paste and just type it out, so that at least I know what I type. Open. P4.txt. Right. Is it different? Using using P4 output and P4.txt. Well, let's find out. Okay. Only, okay. X. Zero, and then S. Okay, this should look the same. And yes, okay. Okay, it now works, right? So what is the difference here? Okay, now let's start changing a few things, like this one. Okay, it is at least different, right? Alright, so this is not the problem. No, but this one, I think this should be no problem too. Okay, follow. Okay. And then and if we put space like this, it should be no problem, right? Let's find out. Okay. And then this. File. Alright. At least that works fine. Maybe we can do this, and then arcs file, right? We are using the array of character instead of the pointer to string constant or string literal, like that. This one's only arcs. Okay. Let's just call it arcs. Something like this. Okay. Array. Oh. Interesting. Let me check. What is it can be for? Okay, it is empty. Why is it empty? If I use printf in here, like what would happen? Character. Like this. Interesting. But if I use this, I need to delete the string header. Okay. Interesting. Let me try. Okay, this one is working. Oh. This is the executable, right? So what about this one? What is the argv? Is it only the argument? For the executable, the argument is available to the new program. Available to the new program. Oh, the first argument by convention should point to the file name associated with the file being executed. So does that mean we need to provide the first argument in argv to the executable file? Then what is the point of this file? Interesting. Yeah, what is the point of this argument then? I'm still not sure where I can take a look at the implementation of execvp here. Okay, but that is something to learn, I guess. And let me try something like this. Empty, and then this one is empty. Yes, that is interesting, right? I mean, why designing the interface like that? I have no idea. Not that make me kind of curious though. Maybe we can kind of see the implementation of XFVP in GTP, you know. And what about something like this? Is it gonna hang again? No, okay, interesting. So if we didn't provide this, we will hang. And funny enough, we didn't get an error. Okay. Interesting. Well, at least we learned something new. We use character instead of how to explain this? I mean, I don't want to accidentally, what is it called? Modify the string literal to prevent accidental vacation in okay, like this. Error. Okay. Open right. This one. And let me also delete the before only, something like this. Okay. this. Oh, wait a minute. I need to remove this and then provide this in here. Okay, GTP. No. Wait a minute. Did the testing of the fog prompted process this one? Okay. Yes. Do we even break when entering the function? I don't think so. Yeah, right. Okay. Let me. What is it called? Let me put a comment in here. I mean, if we, what is it called? If we check this one, right? So let's say we didn't provide executable. We are providing this file. So is it like, what is it called? Is it like we are constantly executing this file? Like, what is it called? Cycling, you know? Is that how it works? You know what? Let me try. Before remove CMD in here. CMD, okay, or something like this. Okay. No. I mean, I expect this to fail because before does not exist. Alright. Okay, well, we need to we also need to provide the executable name as the first array element of the array for exec VP. See, the argument is available to the new program. The first argument, again, I'm not sure if the first argument means the first argument in the argv argument vector here, or another thing. By convention, should point to the file associated with the file being executed. Terminated by null pointer. I assume this means the first argument of the argument vector here, the array of argument. I'm assuming, but yeah, I'm not sure. Where can we check the implementation of this function of this API? I am still not sure. Not sure. We didn't provide as the element of the array. The scripting will hang and we terminate process using strc. This is an interesting finding, I guess. Still not sure. not sure why we need provide in the array of argument when we are ready provided as the argument sec VP. Okay, maybe we will find out one day, but not now. W status something like this. Okay. Alright. Of what? It is copied from the parent. Maybe we are actually closing maybe we are actually closing the standard out first and then open the file. Maybe. Well, let's find out. What? Okay, something like this. Close STT out file descriptor and open the opener create file.txt. Okay, STT out including STT Hello. I cannot read your message. But welcome. We are currently in this section trying to understand the reason why the API for creating a function was split between fork system call, this one, fork system call, and exec system call. And one of the reasons is, well, the Unix shell. So we kind of create a chat process when we use the shell, like bash, zsh, or another shell. And then in the chat process, we are replacing the instruction in this process with another instruction using exec command. So it kind of creates a new environment for the about to be run program, and then the program can use this environment in isolation, maybe something like that. So yeah, and then we are taking a look at the figure 5.4 here. It is kind of using the, what is it called? The redirection concept, I think. And now I'm trying to create a hypothesis of what is going on under the hood. Okay, this is the first time we run the program, right, with the redirection. And then we wait the program to finish. Then we fork the chat process, including std-in, std-out, std-r. Oh, my stomach's growling. Yeah, I need to get breakfast after this. Okay, so in this state, I assume we are already in the chat process, and then inside of this chat process, because we are using redirection, we close the standard out file descriptor and then open file.txt to open or create file.txt. And then after that we execute those, what is it called? Those program, in this case WC, in the chat process, and we are using the file descriptor from file.txt instead of std-out, the standard out. And then after finish, we are returning to the prompt. Okay, something like that. Oh. Now this make me interested. what would happen when I use printf after we already closing the standard out? I mean, if I remember correctly, okay, string like this. Where is it? I think this one. Printf and fprintf will output to standard output stream. So what happened if we already close the standard output but we are using printf? Something like this maybe. Okay. I don't think we need this anymore. Yeah. Okay. Okay, let's check. Maybe in this one. What is it called? It's gone. Alright. Check. Second one. The return value of open is a file descriptor. Okay. So after we are closing out the standard output, we cannot use printf. Is that it? And well, let's try this again. Okay, we are still having the standard out open, so we can print this out. But after it was closed, looks like we cannot do that. I mean, how it goes, we can print this. So this, maybe something like this. I have been seeing this a lot this day. What have you been seeing? Is a live stream about programming, or maybe something like that? Okay, let's take it out close, we can see this. Okay, Oh. Then I shouldn't use this as an error. Let's see. Return 0 on success, on error negative 1 is return. Okay, error like this, error else fprintf printf. Okay. Let's click stream. So it is stream. Or maybe we can use this one, the printf, because we are using the file descriptor number instead of fprintf. Maybe let's rename this to ft. But yeah, let me check. SecVP. Oh, it's in here. Okay. Return value. Return value. Let's call it this return value. Okay, and then return value. Okay, let me make sure. Return value of open is a file descriptor. Okay. New file descriptor, and then put the printf. The format and then the message. Okay. We print info in file descriptor. Something like this. Let's try compiling this one. Okay, right, add info in file descriptor. One. Interesting. So we are using the same file descriptor number as standard output. I mean, if I understand correctly, stdin or standard input having 0, right? And then not that one, output error, and then out, something like this. This is the file descriptor number. So we are using the same file descriptor number. When using redirection, is that it? Interesting. Okay. Unique pipes are implemented in a similar way, but with the pipe system call. Okay. So instead of exec, we are using pipe system call. Is that it? In this case, the output of one process is connected to an in kernel, to an in kernel pipe. Okay, and the input of another process is connected to that same pipe. Thus, the output of one process seamlessly is used as input to the next, and long and useful chains of comments can be strung together. Right? So we are using the previous comment output as the next comment input. Something like that. As a simple example, consider looking for a word in a file and then counting how many times that word occurs. Here is an example. Where is it? Grab what pattern should I use? Maybe return value. In the chapter before.c, and then piping the output of grep to wc to print out the line. Okay. And if we take a look in here, we have 9. 1, 2, 3, 4, 5, 6, 7, 8, then 9. So we have 9 lines that have the word return value. Finally, while we just have okay, let me continue this. With pipes and the utilities grep and wc, it is easy. Just type grep. Okay, I think this means exact word. I don't really remember. Okay, only matching. So maybe it is like the exact match, something like that. I'm not really sure what this means yet. Okay, into the comment room and marvel at the result. Finally, we just have sketch out process API at a high level. There is a lot more to tell about this calls out there to be learned and teaches. We learn more, for example, about file descriptor when we talk about file system in the third part of the book. For now, suffice it to say that the fork or exact combination is a powerful way to create and manipulate process. Okay, let me commit this. like we are using the same file descriptor. Is one. Yeah, I mean, I'm not sure why the file descriptor is one. And maybe I'm kind of curious if we did not close maybe we should give this an initial value. I mean, if we did not close the standard output, what would happen? Okay, and then what about the before? Alright. File descriptor 3. Okay. And this one is open is print out in the standard output. Interesting. I'm using a Copilot like Windows. What? I don't understand. Anyway, welcome virtual, and also welcome Muslim party. Which distro is this? I'm currently using Arch Linux. Okay, Alright, let me commit this. Okay, let me check again. This wait. So even though we replace the program instruction in the chat process, we are still using the same file descriptor. Okay. Cutting the file descriptor. Wait a minute. With cell out of cell redirection. Something like that. Wait the program to finish. Fork to the child process. Okay. Close STT out file descriptor and open or create file.txt, right? And then exec in the chat process with file descriptor from file.txt instead of STT out, and then return to parent process when finished. This is still a question that I'm not sure what is the answer. Why open using STT out file descriptor by default? Is it because STT in already open and the lowest number file descriptor that have not opened yet after STT in is STT out? Yeah, I'm still not sure. Maybe we will find that out during the later chapter. Okay. Close. Right. Looks like we are using the same file descriptor number as STT out. Okay. We use array of character instead of string literal directly to prevent accidental modification of the string literal in another function. Okay. Providing this one. Okay. Let me commit this. What is it called? Let me call this a feature. An example of simplified cell redirection. Maybe something like that. This is, what is it called? It's a simplified process of what is going on. This is the simplified process of what is going on. We are using cell redirection such as which means that instead of using STT out, we are using file.txt to store information. Okay. Let me make sure that Yeah, that make me kind of curious. What is it called? Pivot.txt. Right. Why we assign to file descriptor 1 instead of 0, the standard input? Is it because the standard input ID open or occupied, maybe? I am still not sure. And anyway, let's continue first. Process control and user. Beyond fork, exec, and wait. There are a lot of other interfaces for interacting with process in Unix system. Okay, I'm kind of curious about the pipe API, I guess. Okay, at least we have pipe in the POSIX standard. And with overview of pipes in Vivo. You know what? Let's take a look at the main page, section 7. I kind of forgot what it is called. In section. Okay. So the number we provide here means the section. Main page, section 7. Something like that. Pipes provide an E. How do we pronounce this? An ED or unidirectional. Is that how to pronounce this? Unidirectional interprocess communication channel. Process a read end and write end. Data written to the right end of a pipe can be read from the read end of the pipe. A pipe is created using the system called pipe, which creates a new pipe and return to file descriptor 1 referring to the read end of the file, the other referring to the write end. Okay, now let's take a look at the system call. There is pipe system call and also pipe 2 system call. Interesting. Pipe creates a pipe, a unidirectional data channel that can be used for interprocess communication. The array pipe FT is used to return to file descriptor referring to the ends of the pipe. Refer to the read end of the pipe, and pipe FT index 1 refers to the right end of the pipe. Okay, data written to the right end of the pipe is buffered by the kernel until it is read from the rear end of the pipe. Okay, so it is an array. The pipe system call expect the two, what is it called, an array with two elements, maybe something like that, element of the file descriptor. Okay. In this case, the output of one process. Okay. No, let's continue in this one. Beyond fork exec and wait, there are a lot of other interface for interacting with process in Unix system. For example, the kill system call is used to send signal to a process, including directive to pause, die, and other useful imperative. Okay. For convenience, in most Unix shell, certain keystroke combinations are configured to deliver a specific signal to the currently running process. For example, Ctrl+C send a in interrupt, right? In most Unix shell, certain keystroke or keyboard shortcut combination are configured to deliver a specific signal to the current running process. For example, the Ctrl+C send in signal interrupt to the process, normally terminating it, and Ctrl+Z send a TSTP to stop, or maybe put in the background. Yeah, I'm still not sure what this signal does, but I know put the Ctrl+Z, put the Ctrl+Z. For example, we are in this one, right? In this file, opening Vim, we can use Ctrl+Z, and it is being suspended in the background. If we want to open that again, we can use the fg command or the foreground, and we open Vim again. I know about the Ctrl+Z, but I'm not sure about the signal, the STP. Thus pausing the process in mid-execution, you can resume it later with command. Example, see the FG, the foreground, I call it. Put in command, found in many cell. I'm not sure, is there any main page? Oh, there is a main page. It is the POSIX standard. Okay. Yeah, run job in the foreground, right? So there is that. In command found in many cell. The entire signal subsystem provides a rich infrastructure to deliver external events to processes, including ways to receive and process the signal within individual process, and ways to send signal to individual process as well as entire process group. Okay, this is new term, the process group. to use this form. Okay, I will read the aside after finishing this section. To use this form of communication, a process should use the signal system call to catch various signals, to ensure that when a particular signal is delivered to a process, it will suspend its normal execution and run a particular piece of code in response to the signal. Read elsewhere. To learn more about signals and their many intricacy. Is that how to pronounce it? This naturally raises the question, who can send a signal to a process and who cannot? Generally, the system we use can have multiple people using them at the same time. If one of these people can arbitrarily send signal such as SIGIN to interrupt a process, we can have multiple people using them at the same time. If one of these people can arbitrarily send signals such as SIGIN to interrupt a process, likely terminating it, the usability and security of the system will be compromised. As a result, modern systems include a strong conception of the notion of a user. The user, after entering a password to establish credential, logs in to gain access to system resource. The user may then launch one or many processes and exercise full control over them, post them, etc. Users generally can only control their own process. It is the job of the operating system to parcel out resources, such as CPU, memory, and disk, to its user and their process to meet overall system goal. Okay. Can only control their own process. It is the job of the operating system to parcel out resources to its user and its process to meet overall system goal. Okay. The RTFM. Read the friendly manual. Right? Read the main page. Many times in this book, when referring to a particular system call or library call, we will tell you to read the manual page or main page for short. Alright, in case anyone new to the main page, you can type main like this in your cell, and it will give you a list or the manual for the main page itself. But I think you need to install the MainDB. If I remember correctly, kind of forgot. Yeah, something like this, a utility for reading main page. At least in the Arch Linux, the package called main-db. I'm not sure what the package name in another Linux distro. You need to install this MainDB to be able to read the main page. or main page for short. Main pages are the original form of documentation that exists on Unix system. Realize that they were created before the thing called the web exists. Before the web exists. Okay. Spending some time reading main page is a key step in the growth of a system programmer. There are tons of useful tidbits hidden in this page. Some particularly useful pages to read are the main page for whichever shell you are using. Okay, you can use bash or tcsh or zsh or another file or another shell, and certainly for any system call your program makes in order to see what return values and error condition exist. For any system call your program makes in order to see what return values and error condition exist. Okay. Finally, reading the main page can save you some embarrassment. Okay. When you ask colleagues about some my stomach's growling again. When you ask colleagues about some intricacy of fork, they may simply reply RTFM. This is your colleague's way of gently urging you to read the main page. The friendly manual, right? Just add a little color to the phrase. Okay, yeah, that's why I'm using this main command a lot, right? To read the manual page of the program if they have any. And also, in case anyone curious, yes, I do programming before breakfast, so I will get breakfast after this. I got my OS midterm tomorrow. Oh, you have an exam tomorrow. Good luck with your exam. Sapphire Gaming. Okay. And then the useful tools. Is it a lot? Oh, okay. Well, I think we will continue this on the next section. So that's it for now. Thank you for watching and see you next time. Bye bye.